Good afternoon, everyone, and welcome to the Elite Tips, Tricks, and Tools series, sponsored by Kaon and the Lab Design Tool. Today, we're going to be talking about future-ready labs, how smarter design and agile tools are driving faster time to science. I hope everyone is having a great start to their day so far. I know I am. Before we get started with our presentation today, I just wanted to quickly direct everyone's attention to the QA section of Zoom. This is the perfect way for you guys to ask questions to our presenters throughout the course of this session. We will review them. We will either do them real time, live, interactive, or we can reserve them towards the end, depending on the questions and how the flow goes. So, with all of that out of the way, I wanted to introduce you to today's presenters. I'm going to start with myself. My name is Dana Drissel, and I'm the Chief Marketer at the Lab Design Tool, which is powered by Kaon Interactive. Yesterday, the Lab Design Tool was just named the top 3D Lab Design Tool in 2026 by Construction Tech Review magazine, which was very exciting for us. So we are working to help companies really quickly design and visualize lab layouts in 3D and reach stakeholder consensus 33% faster and really avoid high costly design errors and really accelerate time to science with new digital twins of labs. So with that, I wanted to also introduce you to my co-presenter today. His name is Nicholas. Nicholas, do you want to go ahead and introduce yourself and talk a little bit about Callian?
Yes, sure. Thanks a lot, Dana. Hi, everyone. So my name is Nicolas Rousselet. I've been working in the TICC sector for the past 13 years now. Um, I played several roles around operational excellence, transformation, process digitalization within large companies. And 4 years ago, I co-founded Kalion. So Kalian is actually a Greek word which means better, and this is exactly what we're trying to do with our customers. We offer operational excellence support to laboratories and companies working in the TIC, so testing, inspection, certification, and compliance sector more widely. So it's about consulting, it's about training around operational excellence, and as well as providing IT solutions or products which are really helping our customers on their journey towards continuous improvement. That's about me, in a nutshell.
Thank you.
Thank
Well, so today I'm very excited because Nicholas and I are gonna talk to everyone about something that's becoming absolutely critical across R&D today, in particular, across R&D, actually clinical labs and industrial labs as well. And that is really the mindset of designing lab environments that can keep up with constant change. So we're seeing constant change happening all the time in today's environment. And whether you're working in a pharma or biotech or diagnostic or advanced manufacturing lab, um, we're really seeing that there's no longer static spaces in these environments. They're constantly on the move. They're dynamic, they're high pressure, their environments are fast paced, and we need to kind of adapt to change more now than ever before. So, with new technologies and new workflows and new business priorities in place, what we're looking to do is kind of figure out ways to be more agile in these laboratory environments. So, why this really matters is that with constant change comes a pace we've never seen before. So what we're seeing is that industry data is kind of talking about over 70% of lab leaders are reporting that they are reconfiguring their labs about every 5 years due to occupational and occupancy issues. And nearly 50% of those facilities are no longer fully supporting their current workflows because of the constant change that's taking place. When changes happen, they're very expensive. There's cost of major moves and relocations. There's internal moves within the building for basic relocations. And then there's also going down to minimal, single equipment moves. So the challenge isn't just growth within these environments, but it's unpredictability of these kind of changes, right? So as new instruments come in, new automation is introduced to laboratories. AI is driving data changes of how you want to look at your environments, and you're analyzing that for regulatory shifts, and you're looking at various shifts in talent that are happening in these labs due to shortage of good scientists. They're forcing labs to kind of really evolve continuously. one of the things that we were talking about with one of my customers was that biopharma companies in particular are scaling cell gene therapy labs. And those are often redesigning spaces every 8 to like 24 months to kind of keep up with the process moves and new clinical testing that's taking place. So that's one example of these constant changes. Another one is if we kind of go back and look what was happening about 3 years ago in the COVID era, when we were looking at a lot of diagnostic labs had to be changing to increase output by 2 to 3 times based on expanding footprints and, without expanding their footprints, they had to look at taking their existing lab spaces and be able to get more return from their current space and environment. So doing more with less space, with the same space. So we had to kind of look at how to make those environments more flexible for growth and greater output. When we're talking about change, we're not just talking about cost, like cost is significant, but we're also talking about additional things outside of financial. So impacting delays on research timelines when you're doing major moves and what that can look like. Safety risks that come with overcrowding or workaround behaviors. There's also, high operating costs that are taking place due to inefficient adjacencies in the lab space. So we're seeing that these types of renovations can cost 2 to 3 times more downtime. And really kind of delaying research and getting time to science significantly when you're not able to do them as efficiently as you can. So it can also be very challenging and difficult to attract new talent when your labs aren't set up for success for the scientists. So that's kind of an ongoing challenge that we're looking at. So when it comes to planning and overhead, those are some of the things we're kind of looking at, trying to reduce costs, increase success of output, decrease turnover of staff and labor. And so all of those things can kind of come at a great cost within these environments. Um, Nicholas, I don't know if there's anything you wanted to add to that when it comes to,
Yeah, I can only confirm that this is what we typically observe. Um, and the planning duration is really a key aspect here. And labs today require a lot of flexibility to actually adapt to changing needs, to evolving testing needs, and having a way to reduce that planning is key
yeah,
for
I think
any.
you had previously mentioned something too about when doing these kind of um, moves and relocations. There's also time requirements it takes, I think, for HVAC, various experts, movers, architects to get trained and updated, and those can take a lot of effort and time as well.
Exactly, and finding a way to actually move the instrument without losing any previous validation or qualification is critical. So planning it well ahead is paramount for the process.
Yeah. I think that's why the industry is really moving towards agile and more modular, I would say, lab design. And that's been kind of over the last couple years for sure. So instead of designing labs for kind of a single function, organizations are starting to look at designing more for adaptability and constant change. So companies that tend to use these kind of modular designs for flexibility are really seeing and reporting up to about 30 times faster reconfiguration times as compared to like fixed casework and things along those lines. So I'm going to turn things over to Nicholas to talk a little bit about Calion in particular and some of the tips and recommendations on how to create more flexibility in design.
Thanks, Dana. Yeah, so again, so hi everyone. The objective here is to give you a few elements of a few concepts and few tips and tricks on how we can design flexible space and really work towards structured lab design. If you look at the left, and okay, these are just examples and pictures that we made to illustrate our principles. If you look at the left, this is what we typically observe in labs. A lot of motion, people walking between the workstation because you have put all the ovens in one place, all the HPLCs in the other one, all the fume hoods are in another area. And it's what we observe typically, a lot of motions, 35 to 40% of staff time spent walking, large footprint, as you see in large corridors. The workspaces are dedicated to one specific function, meaning that when that test, that operation, that activity becomes less frequent, then well, that space becomes less occupied, and more often than ever, this space is in the middle of the lab. So meaning that you waste some space. And if you have longer walking distances, this is typically advocating for longer lead times because people tend to batch process multiple samples in one area before transporting them to the next one, so which creates as well longer lead times. What to really go towards, and the next slide, I'm going to explain you a little bit how we go to the right area. This is really about flexibility. So if you go for a lab design structured one, and so to the lab design, sorry, we typically recommend to go in a sequence. First, it may sound obvious, but this is really the step which is maybe the most critical, is about defining the requirements. What do we want to do in that lab? What is the scope? What are all the internal and external processes? Which regulation are we going to work with? Are we working under GMP? Are we going to work under ISO? Which one? This is a set of questions which really help to structure the design. How are we going to manage our consumables? What are the constraints that we have? Do we have some walls which can be moved? Where are fire escapes? How many fire escapes do we need? All this is critical, and which will help us to define, okay, a macro area. What do we want to put where? This is where we go towards the topic of work cells. Work cells are our like main building blocks. Where do we put them? How can we ensure that we have modularity? How do we place them in a way that the flow, and this is the next point, will be well optimized? How do we place the work cells to ensure that they can collaborate with each other? How do we access them for core activities or for support activities? How can we easily take the waste out of the work cell? Then we define the flows: people, consumables, sample, and waste. But we think as well about the data flows. Where do we need to have computers? How do we want information flowing from one workstation to the other? Is it purely LIMS? Do we want to have some paper? In some labs, we need to have a lot of paper still. Also, it's not ideal. This is part of the quality management systems. So how do we want to transfer all this paper, this information? And finally, we go towards the workstation design, because in a lab, people are a super valuable asset. So how do we design ergonomic workstations where we use a vertical space as much as possible, a visual space where every information is available at best place? But what is key in all of that is the modularity, because the lab needs will evolve. So how do we plan the lab for today, but as well for in 5 years or in 10 years? And this is why all this flexibility, this modularity will be helpful. And here we go towards the shape of our work cells. Typically in lab, we can see long straight lines, long straight benches. This is what we observe in most of the labs we enter. And this creates a lot of staff motion. This creates an inefficient space utilization, and the workstations cannot really cooperate with each other. What we really typically advocate to go for is what we call this L shape or U shape work cells. You reduce significantly the motion of the staff, the space is better utilized, and you create some protected space for people to work in and to transfer samples. You can imagine in this U, at one end of the U shape is the input area for samples. People can process it within the U, and at the other end of the U is the exit area for samples, which can then be distributed to the next workstation in an easy way. And this is really why we go for this kind of a workstation where flexibility of operation is increased. If you can go to the next slide, please, Dana. This is really another way to illustrate that with the topic of flow. What we observe when we recommend in laboratories as well is to really focus on the flow, because a flow of, sorry, an analysis is a sequence of different activities, and some of the activities can be common between different flows. And if you design your laboratories without thinking about the flow of operations, then you create some areas uh, of congestion where everyone wants to use the same balance, the same oven, the same automate, the same instrument at the same time, because the lab was designed not per flow, but per type of activities. On the opposite, if you think about flow, then you create work cells which are dedicated for a certain flow, which you can afterward mirror, which you can duplicate when volume increases, or that you can recommission for another type of flow when the properties of the lab change. And organizing the steps per value stream helps to group activities together and staff as well the work cells in the best manner to align with the demand of the lab on a daily basis. If you can go to the next one, please, Dana. Thanks a lot. And this is another key aspect around the workstation and the work cell design is to consider not only the sample processing, which is a typical and which is actually the main objective of a lab, but is to think about all the other activities happening around. So if you think about it on the left side, between the benches, what you will have is an area which is used at the same time for the maintenance and the distribution of consumables, as a workspace, and as a walkway and a sample distribution area. When we enter in labs, we typically try to play a game which is a move the chair game. And we observe how many times a chair, which is basically sitting in front of a bench, is moved out of the way within 10 minutes. And sometimes it can be dozens of times because the area isn't protected. And so we ask ourselves the question, how can someone work in that area in a really calm and concentrated manner? The answer is you cannot. And this is why we really try to go for the design that you can see on the right area. In this green space, which is within the U, it's a safe space. It's a protected area. No one will bump into you when you are walking there. Plus, you can have two people walking together in a conjunction. The yellow part is really dedicated as a walkway and as a sample management area, but as a walkway, meaning as well that this is an escape route. In case of any safety incident, this is the area to use to leave the building. And when we design labs, we typically start by building these big highways, which are the escape routes for people to move. And finally, you can imagine here in the brown areas, flow racks where someone can replenish some consumables without you being in the green area, being disturbed in your operations. So ensuring faster processing of samples. So this is another reason why we really typically recommend to go towards this kind of design. Yeah, maybe my last really critical point I really wanted to insist on is about the mentioned flows a lot, but I wanted to highlight that we have multiple flows. First, of course, is a sample flow. Sample must move always. A sample which is not moving, which is standing somewhere, means a customer, meaning being an internal customer or an external customer, is waiting for a result, is waiting for an answer, which can be critical. So sample must always move as fast as possible and not be relying on people to transport them, if possible. Second point is consumable must always be available where you need them. Because how often does it happen in a lab that technician or analyst stops what they're doing because they need to go to a warehouse somewhere and pick up a consumable, pick up a column, pick up gloves, pick up a pipette? This happens too often. So how do we design the space to have these areas to store consumables close to the point of use? Then people are a valuable asset. You really want to ensure your technician, your staff, your analyst, your trained people are used to the best of their skills, meaning that you do not want them to be spending 35 to 40% of their time moving because the lab was designed in a way that it forces them to move. Of course, people should move. It's really good for health, but they should move when they decide to move, not when the process or the lab design forces them to move. This is where the difference lies. And last point is the process waste. Too often we forget about that flow when we design labs. So what is the flow? What is the route? What is the process to get the process waste, cardboard, chemical waste, bio waste out of the flow without mixing with the samples? So these are all the flows to consider as part of the structural lab design from our perspective. And in the last slide, we made just uh, an example of what we mean by workstation and work cell. It's pretty uncommon to see this kind of setup in labs. We're more accustomed to long, like white and glass top benches. But this is what you can observe in some high volume labs. So everything using vertical space. You can see on the left here that we have three workstations which are exactly the same, meaning that if you have low volume, you use only one, and then if you have more volume, you can use three of them. There is not one workstation for more than one activity. It's everything can be duplicated and as such increase the flow of processing in the lab. And the conveyor on the left serve as distribution to have the samples flowing, moving without human intervention. So yeah, there are just a few examples of what we can do to design. With Scalion, we have been designing now over 100 labs in the past years. So we really have seen all this kind of needs, this kind of constraints, and this was kind of a high-level summary of the key recommendations we can give in this aspect.
Thank you, Nicholas. I think that's a great recommendations on tips on how to lay out the space tactically. And I think some of the things we're going to talk about next are the tools that are going to allow both designers, space planners, um, even on occasion lab managers and scientists to find ways to kind of create and design those more agile spaces quickly. So what we were seeing in the marketplace was kind of this gap between the current state of planning tools, which a bunch of individuals we've seen are using. We had one customer, a large independent laboratory, that was literally going out to a basketball court and using chalk and cardboard to lay out their spaces, and they'd refine it and refine it. We've seen customers using graph paper, a lot of people using PDF documentation where they lay out their floor plans and kind of put sticky notes on top of that, PowerPoint slides to be able to lay out their spaces. The challenge with all of that is it's very antiquated, it's very slow, it's very inefficient and not realistic of what your lab environment is going to be. And when you need to make changes, it's very difficult. So there's a very kind of 2D state of doing something on the far left side. On the far right side is the current state, which we're using a lot of really CAD tools. They're maybe not very expensive in cost, but they take a lot of time and resources and have specialty needs for people who have to be trained on them to leverage them, use them. And so they are very complex to use. It takes time to lay those things out. They require training and trained teams and skills to be able to use them. And oftentimes, their scientists and lab operations teams are being asked to get educated on these kind of tools and become experts on them. And so what we were looking to do is kind of find that middle ground. How can we create something that's very easy to use, that allows for more collaboration? Because oftentimes when you've got these CAD renderings and you're showing 2D floor plans to a scientist, they're still not comprehending and visualizing truly what that environment's going to look like. And how can you make these changes in real time instead of going back and forth with an architect, which can take weeks and can be very expensive? How can you make those iterations and changes very, very quickly and in a very agile way? And that's why we started looking to develop the lab design tool. So there's an imperative for real-time lab planning. We want to move people from those traditional um, tools that are they're really assuming that there's not a lot of change happening in environment. 2D floor plans, you're looking at them, they're slow, they are slowing down the scientific process. There's constraints on innovation. We want to move people to the more modern way to look at these real-time lab designs. And so starting to look at digital platforms, digital twins of your lab space. These kind of technologies are being adopted by leading biopharma independent labs so that they can really adapt to these environments and make more flexible lab spaces at scale really quickly, which helps them then reduce operational risk, reduce downtime in their lab, and create a faster output and faster time to science. So, with those kind of things in mind, that's when these digital planning tools become more critical. So, instead of relying on these 2D floor plans, organizations can now model different scenarios in real time and help really reduce the time it takes to do simulation and planning. And specifically in this digital phase of design, it can reduce change orders by like 25% when you're doing projects because you're getting stakeholder consensus that much quicker. So what I'm going to do now is I'm going to turn things over to Andrew Strout, who's our lead developer for the lab design tool. Andrew's going to kind of walk us through a quick overview of the lab design tool, just demonstrating the ease of use and how the tool enables real-time 3D design planning and lab optimization. And again, just a reminder to everyone, as you come up with questions, QA questions, please feel free to put them in the QA chat and we'll review them and share them with everyone. So at this time, I'm going to turn things over to Andrew, who's going to share his screen and walk you through a quick demonstration.
Great. Thank you, Dana. Wonderful. So I'm just going to share really quickly a very quick overview about how the tool works. Again, there's all kinds of things it can do we won't be able to get into very briefly, but I'm going to start with this blank space here. As Dana mentioned, the goal of the tool is to make it really easy to pick up and use. You don't have to have months of training or anything like that. And we do everything as much as we can with a drag and drop interface. So to start with, in order to create some walls in the space, all I have to do is just click and drag. I start to make my walls. And then from there, we have this little handle right here that you can drag and you can create any sort of room shape that you want. There's some helpful snapping as you move things around to line up to other walls in your space. And as soon as you complete a shape like this, it fills in all those walls with a sort of floor texture right there. And you can see, even as I was doing that, one of the primary features of the tool is this sort of live 3D view down here. So as I add things to the space, again, we have this big giant library of 3D assets over here. As I drag and drop things from that interface into the space here, you can see them appear in that 3D view right there. And as I move them around, that 3D view live updates. Just going to drag a couple of different instruments in here. We'll add a workbench, put a centrifuge on it. I'm just going to make a very simple space. And at any point, you can expand this 3D view. This is a live view. You can spin around here. You can also drag to look around, move that camera, or click and hold on the ground, and you can start entering the space into first-person mode. You can sort of walk around your space. And as Dana mentioned before, get a really immersive, much more relatable sort of view about what your lab is going to look like, much more than just a PDF of squares. I'm going to switch over to a more complete lab really quick to show a couple more things. Great. So we have a few features I want to talk about here really quick. Again, there's all kinds of things this tool can do. Can't get into all of them. We have this option right here for a camera fly-through, which is basically a way for you to really easily just sort of, again, with that drag and drop interface, add this sort of smooth path through your lab to indicate, hey, I want to make a video basically of a camera, sort of almost like a dolly moving along this line. You hit this view button, we can see kind of what that looks like. So it's not just user initiated navigation, which we do have. You can walk around the space, whatever spot you want. You can also set up things like this, where you have these very cinematic sort of camera views, or basically indicate, hey, this is the path you're going to walk. Here's what it's going to look like. You have this nice 3D view that you can export as a video or just view live in the application like this at a nice smooth 60 frames per second here. Great. Aside from just laying out your laboratory, which is obviously very important, we have some tools in the top right here that allow you to perform some analysis on the space as well. And again, not going to go into all of them, don't have the time, but I'm going to talk really quickly about rooms, for instance. So this is basically a way for you to define areas in your space and get some information, some analysis about those areas. So I've sort of predefined a few areas in here. I've got this 1, 2, and 3. And I click on one of these rooms, I have this analyze button right here. And what that does is it gives you these numbers here that basically say, hey, how much floor space is in this area? How much have I utilized? What percentage of that is active right now? Same thing with bench space. And it's sort of, instead of having the sort of top-down thumbnails of everything, it turns it into primary colors so you can very easily see what's used and what isn't. You can do that for any of these rooms and get that information. On top of that, a new feature that's coming very soon is this idea of paths, which allows you to, in the space, you can define sort of a path that a user is going to walk and get information about that path. So if I know someone's going to start here in a workflow, right, and then go to this computer and then go to this instrument and then go to this instrument, we have this very easy sort of drag and drop interface that creates this shortest path possible between all of these different spaces. You can see how far each one of those spots is, give it a different color. We can define how often that path is walked in a day. So for instance, if I know generally someone's going to walk this about 20, 25 times in a day, you can see sort of the total daily distance that they walk. And the idea with this is that you can create a new layout, move those instruments around, and then check how that affects your paths and see how the distance changes. So you can make these rapid iterations, move things around, and get really quick insights on, okay, now someone has to walk from here to here to here. How does that affect the distance that they're walking? How can we optimize for that? Like Nicholas was mentioning earlier. I think I might have hit my time limit, so I'm going to stop my share and pass it back over to Dana.
And Nicholas, you're leveraging this tool as well, correct?
Whatever we can, whatever we have a big prerequisite customer, or even to demonstrate in a small area the impact of structural lab design, we really use this tool to demonstrate how the space can be optimized. And I have to admit that this feature about the walking distance is something which was really important for us, and I'm really happy that it's coming now live into the system, because hey, let's face it, we can really demonstrate the fact that 35 to 40% of time is spent walking. Oh, I think Dana, you're showing your presenter view and not the full screen.
Thank you.
Yeah. So again, I mean, we use the tool and we leverage it as much as possible, and the ability to make quick iteration, and as well, honestly, the ability to make exports that can go directly to CAD and be used directly by architects has been proven extremely useful over the past years. And here you can see something that we designed as well in this tool as a demo.
Yeah, so I think to your point, it's allowing our customers to really do multiple scenario planning very quickly, get consensus and buy-in, again, in a way that builds scientists' confidence because they can visualize themselves in those environments. In addition to what you saw Andrew doing in 3D, this tool also allows you to use augmented reality and virtual reality to immerse yourselves into those environments to see them as well. So creating that 3D rendering of navigation and flow, you can literally immerse yourself in and experience. That all comes as part of the tool. And what we've seen is that 100% reduces the amount of time it takes to get stakeholder buy-in from CapEx teams, from the scientists, from management, from health and safety, right? From all those individuals, from architects who need to be able to see how you want to modify a space or plan. And it's really created reduced time for projects, which then turn into return on getting your products to market faster. specifically for R&D. So we've seen measurable financial returns and accelerated timelines based on these kind of digital twins and visualization tools in the marketplace. I just referenced some of them. You can kind of see some more of those cost avoidances that happen when you're just even trying to move one piece of physical equipment into a space, but it doesn't fit in the door, or you can't get it under the fume hood that you need, or it's not near the electrical box that you need it to be, and you've got to hire a mover to come in and fix it, or you've used an extension cord and burned out that product. That's going to cost you $10,000 plus right there. So these kind of solutions is a no-brainer in moving beyond the 2D into the more modern digital planning of kind of where organizations are heading to be more agile and create faster time to science. So I just wanted to see if there were any last minute questions that came up. I know I saw one that had come in for Nicholas, in particular for Kalion, and what kind of, in addition to the services you offer for design, do you also offer consultancy services?
Yes, yes, we offer training because we believe that any transformation starts with people. So we really want to ensure that the staff is aware of all the concepts, but we do as well consulting. It can go from a diagnostic of the current operation of an app towards complete transformation support, redesign of some selected areas using, of course, the lab design tool. Yeah, so this is what we do, and I'm always happy to have a conversation with you if you are interested in discussing this more in detail.
Perfect. We are I don't see any other additional questions coming in, so and we're close to time. So in summary, just for today's lab environments, obviously are demanding more adaptability due to the constant change that's happening in the marketplace. The most effective organizations are planning for this flexibility and are really truly digitally transforming their processes to evolve alongside the science. So I welcome everyone here to please reach out and feel free to contact Nicholas and myself on LinkedIn if you have any questions, or if you'd like to get a demonstration of the lab design tool or talk to Nicholas about their services, and specifically how we compare Calion's consulting services with the lab design tool. It really helps in creating more it's shifting teams to kind of really look at reactive fixes and being more proactive in their planning and cutting time and costs, and really removing inefficiencies from the process. So we look forward to supporting you guys as you're creating your future ready labs. And please feel free to reach out at any time with questions. So thank you everyone for joining us. Thank you very much, Nicholas. I appreciate your time today. It was
I appreciate it as
fantastic.
well.
And I look forward to doing this again. So thank everyone for coming. Appreciate it. Have a
Thanks a
great,
lot.
thank you.